Okay, so in this video, we're going to solve the trig equation sine of x plus tangent of x is equal to 0 for all values of x in the interval 0 to 2 pi inclusive. So we know we want to look for radians instead of degrees. And if we look at our trig identity hexagon, we can see that tangent is the ratio of the sine divided by the cosine. So we're going to start by using that quotient identity and rewrite this equation as sine of x plus sine of x over cosine of x is equal to 0. Okay, now in order to combine these, we're going to need a common denominator. So I'm going to multiply the sine of x in this first term. We're going to multiply that by cosine of x over cosine of x because that doesn't change its value since we're multiplying by 1. And then that's plus sine of x over cosine of x equals 0. Okay, now we'll multiply straight across, so sine of x, cosine of x over cosine of x plus sine of x over cosine of x is equal to 0. And now that we have a least common denominator, we can go ahead and add these fractions by adding straight across the numerator. So we'll have sine of x, cosine of x, plus sine of x, all divided by cosine of x is equal to 0. Okay, and then from here, we can cross multiply in order to solve this proportion, and so this numerator times 1 is just the numerator, so sine of x cosine of x plus sine of x is equal to, and then on the other side 0 times anything is 0. Okay, now we can see that we've got a sine of x in each term of this binomial, so we can go ahead and factor that to the front as the greatest common factor. And we'll have sine of x times the quantity cosine of x plus 1 equals 0. And now that it's completely factored, we can solve by setting each factor equal to 0 using the 0 product property. So sine of x is equal to 0 and cosine of x plus 1 is equal to 0. And then we solve those one at a time. So if sine of x is equal to 0, then we take the inverse of both sides, and x is equal to the arc sine of 0. And that's asking the question, where on the unit circle do we have a y-coordinate of 0? That's going to be at 0 and at pi. So if we were just to sketch out our quadrantal angles here, this is 0, pi over 2, pi, 3 pi over 2, and then back again to 2 pi. And at 0 radians, which is coterminal with 2 pi radians, the coordinate there is 1, 0. So it has a y-coordinate of 0, which means it would work here. So x could be equal to 0, or x could also be equal to 2 pi. Since we have brackets on the interval up here, that means it's inclusive, so 0 and 2 pi both need to be part of that solution set. And then x could also be equal to pi. That would be a third possibility, since the coordinate here at pi is -1, 0. It has a y-coordinate of 0. Okay, now we'll take a look at this other equation. We'll subtract 1 from both sides, and cosine of x is equal to -1. And then we'll take the inverse of both sides, and x is equal to the arc cosine of -1. So that's asking us where on the unit circle is the x coordinate equal to -1. And if we look back up here again at our quadrantal angles, the x coordinate is -1 only right here at pi. That's the point -1, 0. And so x is equal to pi would be the only solution to that part of the equation. So now we need to go ahead and check these answers in our original, which was right up here. So we're going to go into the graphing calculator next. And we want to first make sure that we're in radian mode. So check that mode. And then we're going to store pi as the x value. So pi store x and then enter. And then we're going to type this equation, sine of x plus tangent of x equals 0. So sine of x plus and then tangent x. And to get the 0, we go to second math, or to get the equals, second math, and then number 1, and then the 0. Now, whenever you use the equal sign in the test menu, that's asking the calculator a yes or no question. So it's going to substitute in pi for everywhere we have an x in this equation, and if yes, it checks, it'll return a 1 when we press enter. If it doesn't check, it's going to return a 0. So we press enter and we get a 1. So that tells us that pi is a solution. Now we're going to store 2 pi as the x and press enter. And then we can arrow back up to the equation and press enter to copy it so we don't have to retype it. And again, we get a 1, and so it checks. Then we'll put in 0 and store that as the new x. And then last but not least, we check and it works. And so this equation has 3 solutions at 0, pi, and 2 pi.